Hello students. So in the previous class we have discussed so many stability analysis methods like RH criteria, Bode plot, and Nyquist plot is one of the method to find whether the system is stable or not. So we will discuss how exactly this Nyquist plot will helps you to find the stability of an system. So we have the formula Z equal to P plus. We'll discuss these in detail how exactly these Z equal to P plus N is a main formula for Nyquist criteria, where Z is a number of zeros of Q of S for the roots of characteristic equation and right half of S plane. Then N is the net encirclements around the point -1 plus J0. So the clockwise encirclements are taken as positive and anti-clockwise encirclements are taken as negative. So then P is a number of poles of G of S, H of S or Q of S on right hand side of S plane. So we'll discuss for the closed loop stability, Z must be 0. Z will be 0 if both N, P, N are 0 or when P is equal to minus N. This is a condition for what? Nyquist criteria. So we'll discuss procedure, how exactly this Nyquist criteria takes place. Procedure for using Nyquist criteria. The first one, plot the poles of G of S, H of S on S plane and find P. Means you need to find number of poles, right? So next, perform the conformal mapping or find the image of the contour AB closing the right half of S plane on G of S, H of S plane. Then determine the number of encirclements around -1 plus J0. So this will discuss while solving the numericals, right? So this is a standard Nyquist path of an to find stability of an system. So here we have taken its origin, just right side of that origin means right half of S plane. So this is a boundary. So it is starting from O or 0. So A, B, C, D, E, F. Right. So its radius is what? R tends to infinity. If any roots or poles and zeros falls in this range, means right hand side of S plane, so we can say the given system is what? Unstable, right? So that's what we are finding, Z equal to P plus N. Z must be 0. So this is we have the third step, that is determine, we need to what Z equal to P plus N. If Z is 0, the closed loop system is what? Stable. So we'll discuss basic one numerical, how to find stability of a system using Nyquist criteria. Using Nyquist criteria, investigate the stability of a closed loop system whose open loop transfer function is given by G of S, H of S is equal to K by S plus 1, S plus 2. Solution goes in this way. In the step 1, we need to plot the poles. How many poles we have here? 2 poles. One pole is at located at -1. One more pole is at -2. So this is what we have located, -1, -2 with the cross lines. This is what? S plane, sigma versus J omega. Since both the poles of G of S, H of S lies on left hand side of S plane, see here, this is the left hand side of S plane. Therefore, P equal to 0 means no poles on the right hand side of S plane. This is the first step, right? After this one, we need to find image contour, that is to find the image contour of ABCDA in G of S, H of S and N. So to find N, so we need to follow this path up. To find the image path AB, so you need to equate this path AB and then how exactly it will done. See, put S equal to J omega in G of S, H of S. We have the G of S, H of S here given. Here in the place of S, you replace by what? J omega. The end. So you'll get what? 10 by J omega plus 1, J omega plus 2, right? So if you want to find the magnitude, so that will be 10 by under root omega square plus 1. Its angle is what? Tan inverse of omega. Then into. So omega square plus 4 tan inverse of omega by 2. So total. So 10 will be as it is. Angles are taken in the numerator. See, if you take this one tan inverse of omega numerator, it will become minus. This also minus. So magnitude will be what? Omega square plus 1. So when you substitute omega as 0 in this equation, so you'll get the magnitude as with a 5 with an angle 0 degree. So that point we call it as A dash. Right. So if you substitute omega equal to infinity in the above equation, so you'll get 0 as the magnitude, minus 180 degree as an angle. That point we'll call it as what? B dash. The net angular variation from A dash to B dash is what? Minus 180, means 0 to minus 180. Hence, G of J omega, H of J omega locus can lie only on two quadrants having the angular variation from 0 to minus 180. Means this is 0 degree line. So this is minus 90, this is minus 180. Means the contour will come in this way. So you can observe here this AB, now it is changed to what? So in this way, A dash, B dash, right? Then the section 2, to find the image of an path BCD. So you need to find this path BCD. So its equivalent contour. How exactly it is? See, we have equal to what? Limit r tends to infinity r e raised to j theta in the g of s h of s. Therefore, that equation will change to what? Limit r tends to infinity 10 by, where the s is there, we need to replace by what? R e raised to j theta. Here also r e raised to. If you multiply this 1 and 2 is the least quantity, so you can rearrange the terms like 10 by r e raised to j theta into r e raised to j theta, right? So if I apply the limits here, limit r tends to infinity 10 by r square e raised to j 2 theta. So that is limit r tends to infinity 10 by r square into 1 with an angle 2 theta, right? So at the end, if I substitute r as infinity, so I'll get magnitude at 0 with an angle minus 2 theta. See here, the angle variation from here is what? 90 degree, 0 degree and minus 90 degree. See here, that we can show here. The 90 degree, 0 degree, minus 90 degree. If I substitute those, so I'll get minus 180 degree to 0 degree to 180 degree. So these points can be called as B dash, C dash, D dash. With the magnitude as what? 0 means this point will be at the origin. So that I can show you. See, B dash, D dash, right? Now, to find the image of an path DA, means this is the path DA. So it is minus 90 to 0 degree. So you need to find D dash, A dash now. How exactly you can find out that? See, let us see. See, path D dash, A dash is a mirror image of A dash, B dash with respect to the real axis. This is what the real axis. We know how exactly the A dash, B dash. So it looks like this. So if I take B dash, A dash, so this will be in this way. That is a mirror image that we have shown with the dotted line, right? After finding these contour, A dash, B dash, C dash, D dash and D dash, A dash. So complete Nyquist plot will be like this. A dash in this way, see the direction, B dash, C dash, D dash here itself, then D dash, A dash. So this is the magnitude of how much? 5. This magnitude we have obtained. So in the first section only. See here, this is the magnitude 5. Now need to find encirclements now. Where is minus 1 plus j0? Here. So whether this Nyquist plot encircled this minus 1 plus j0? No. So it is nowhere encircled this point. So therefore number of encirclement for this Nyquist plot, that is n, will be what? 0. That the same thing here explained here. Since minus 1 plus j0 point is not encircled by the plot A dash, B dash, C dash, D dash, A dash in the G of S, H of S plane. So we have n equal to 0. So we have found out P also initially in the first step. You can see here what is the value of P here. So P value is what? 0, means no poles on the right hand side of S plane. So we got P value as 0 as well as what? N value also 0. The N value also 0. Now to find the stability of a system using Nyquist criteria, we have the condition. What is that condition? Z equal to P plus N. Substitute the value of P and N here. P is 0 or N is also 0. So therefore Z is 0. So then comment will goes in this way. No roots of the characteristic equation lie on right hand side of S plane. Hence the closed loop control system will be stable. Right. So if you got Z as 0, so obviously we can say the system, given system is what? Stable. So this is how need to find equivalent standard Nyquist plot to what? Given numerical and its contour by drawing with the technique, and then find the number of encirclements as well as P and find the Z value. Depends upon Z value, so you can comment the system stability. So this is how the overall procedure of the neck piece problem. Rest all the things we'll discuss in the next class. Thank you.